In the vast expanse of the cosmos, galaxies swirl and shimmer, each one a testament to the universe's ancient mysteries. Among them, the Andromeda galaxy stands out as a luminous neighbor, a majestic spiral some 2.5 million light-years from Earth. For centuries, it has fascinated astronomers, inspiring questions about the origins and fate of galaxies, and perhaps the universe itself. Recently, however, the Andromeda galaxy has become the focal point of intense scientific intrigue, as data from NASA's James Webb Space Telescope has revealed phenomena so unexpected, they are challenging the very foundations of our understanding about the cosmos. When the James Webb Space Telescope, the most advanced space observatory ever launched, turned its gaze toward Andromeda, scientists anticipated a wealth of high-resolution images and detailed spectra. What they did not expect, however, was to be met with a series of baffling anomalies, signals and structures that defy explanation by current cosmological models. One of the most striking discoveries is the detection of an unusual rhythmic pulse of radiation, emanating from a region deep within Andromeda. Unlike the steady glow typically expected from galactic cores or star-forming regions, this signal oscillates with a regular cadence, pulsing like the beat of some cosmic heart. Surrounding these pulses are regions of intense heat, measured at temperatures far exceeding those found in similar galactic environments, encircled, paradoxically, by vast areas of almost eerie stillness and minimal activity. This peculiar arrangement has left astronomers puzzled. Traditional models of galactic dynamics predict that energy and matter should be distributed more evenly, with hot regions blending gradually into cooler ones, and any rhythmic signals explained by known phenomena, such as pulsars or rotating neutron stars. Yet the patterns observed in Andromeda are different, suggesting the presence of previously undetected structures or processes operating on scales and in ways never before seen. Compounding the mystery, the James Webb Telescope's high-resolution imaging has unveiled significant asymmetries in Andromeda's system of satellite galaxies. Of the 37 known satellites orbiting this galactic giant, an overwhelming majority appear to be aligned toward the Milky Way, a striking deviation from the near-spherical or isotropic distributions expected in standard cosmological theories. This lopsided arrangement poses a direct challenge to the prevailing understanding of galaxy formation and evolution. For decades, astronomers have believed that satellite galaxies are captured and distributed more or less evenly around their host, influenced by the gradual pull of gravity and the chaotic dance of cosmic matter. The pronounced asymmetry observed around Andromeda suggests a far more complex history, one that may involve dramatic past interactions, perhaps with the Milky Way itself, or the influence of dark matter in ways not yet understood. For the scientists on the James Webb team, these findings are both exhilarating and unsettling. On one hand, they represent the cutting edge of astronomical discovery, proof that the universe still holds secrets waiting to be uncovered. On the other, they force a reckoning with the limitations of current models, highlighting gaps in knowledge that must be bridged if humanity is to fully comprehend the workings of the cosmos. What then could be causing these anomalies? Some researchers speculate that the rhythmic pulses of radiation may be the signatures of exotic astrophysical objects, perhaps something akin to a magnetar, but on a scale and with energy outputs far beyond anything seen in our own galaxy. Others suggest the possibility of interactions between massive clouds of dark matter and ordinary or baryonic matter, a process that might generate intense bursts of energy and create the surrounding zones of inactivity. The unusual heat distribution, too, remains a puzzle. One hypothesis posits that these hot regions could be the result of massive, unseen collisions between star clusters, or even the remnants of smaller galaxies consumed by Andromeda in its ancient past. Such collisions would release vast amounts of energy, heating up the surrounding gas and dust, but the precise mechanisms by which these hot zones are isolated from their cooler neighbors are yet to be explained. The asymmetry of the satellite galaxies, meanwhile, raises profound questions about the history of Andromeda's interactions with its surroundings. Could it be that the gravitational pull of the Milky Way has subtly but inexorably drawn Andromeda's satellites toward our own galaxy? Or do these alignments point to an entirely new kind of galactic behavior, perhaps influenced by large-scale cosmic flows or the presence of unseen massive structures in the intervening space? These discoveries underscore the need for a comprehensive re-evaluation of galactic formation theories. The unexpected signals and structural anomalies observed in Andromeda suggest that our current models may not fully account for the intricate processes governing galaxy evolution. Ongoing and future observations, particularly those utilizing the James Webb Telescope's advanced capabilities, are essential to deepen our understanding of these cosmic phenomena. For now, the scientific community is abuzz with speculation and excitement. Teams of astronomers around the world are poring over the new data, seeking patterns and clues that might explain the anomalies. Theoretical physicists are revisiting old equations, probing the limits of established models, and developing new hypotheses to account for the observations. And the engineers and operators of the James Webb Telescope are preparing for follow-up observations, searching for additional evidence that might illuminate the nature of these cosmic mysteries. In many ways, this episode is a reminder of the fundamental unpredictability of scientific discovery. Each advance in technology, each new window onto the universe, has the potential to upend our assumptions and force us to see the cosmos with fresh eyes. The James Webb Telescope, with its unprecedented power and precision, is doing just that, revealing a universe more complex, dynamic, and enigmatic than previously imagined. As we await further data and analysis, one thing is certain: the Andromeda Galaxy has not yet yielded all its secrets. These alarming signals and structural oddities may be the harbingers of a new era in astrophysics, one in which long-held theories are revised or replaced, and our understanding of the universe is transformed. For the scientists at NASA and around the world, the challenge is clear: to embrace the unknown, to follow the data wherever it leads, and to unravel the mysteries of a cosmos that is perhaps stranger than we ever dared to dream.